Okay, you guys, so I'm going to do an example for you for the dependent samples t-test so that you can kind of see me walking through the process up here, and hopefully that'll help you out a little bit. So in this particular example, we have 4 students and we are looking at their before and after scores. I'm going to ask you to imagine that we are looking at how stressed out students are before they come and see me versus how stressed out they are after they come and see me. And hopefully we will see change, right? And my goal is obviously that after they come see me, they're going to be less stressed out than before. Okay, so if we're starting at step 1, we really need to work on hypotheses, and this can be a little tricky here for our dependent samples t-test. If you remember, let's see if I can put them down here. So for our research hypothesis, we're working with the mean of the d-scores. And the big thing right here is I got to figure out, am I expecting my mean of my d-scores to be greater than 0 or less than 0? If it was two-tailed, I could just say not equal to 0, but here I'm going to do a one-tailed test. The thing that's sort of tricky here is that whether or not I say if is it greater than 0 or if I say if it's less than 0, it has to do with how I decide to do the subtraction up here for my difference scores. So if I do 10 minus 7, that'll be a 3. And then I would be saying, oh, I'm expecting positive difference scores. But if I do 7 minus 10, that'll be negative 3. And I will say I'm expecting negative or less than 0, so negative difference scores. So I'm actually going to do it that way because we didn't do that way in class with the negatives. So I'm going to show you what negatives look like here. So I'm going to do after minus before. So I'm going to say negative 3. And to me, that's communicating that they become less stressed after they come and see me. So 5 minus 6 is negative 1. 4 minus 8 is negative 4. 3 minus 7 is negative 4. Okay, so my difference scores are all negative. I know that that's what I'm expecting to have happen. So for my research hypothesis, I'm going to say the mean of the difference scores should be less than 0 because I expect these numbers to be negative. My null hypothesis then, I've got the mean of the difference scores. It's going to be greater than or equal to 0. Okay, because remember it has to cover all the other options. Okay, good. So that's step 1. Step 2 is figuring out, basically we have to get to our standard error here. Remember I told you that once you have your difference scores, you sort of can like draw a line here. Nothing over here matters anymore. This is your new X column, essentially. And so we need to find a mean of this D column. And so remember, the D with the bar over it is the mean of the difference scores. So I'm going to grab my calculator because I don't have you guys here to sort of do all this number crunching for me. Okay, so I've got 4, 4, 1, and 3. So that's going to end up being negative 12. Okay, so I've got negative 12 divided by however many scores there are, which there are 4 scores. So it looks like my average is going to be a negative 3. Okay, so that is the average. All right, so remember we're following this variance formula. So I'm going to do D minus D bar, which is the same thing as X minus M. So this is a little tricky, and this is why I'm doing one with negative numbers, just so you can see sort of how this works. Because it's basically like negative 3 minus a negative 3. Okay, and if you remember from any of your math classes, when you do minus a negative number, that turns positive. So it's basically going to be negative 3 plus 3. Okay, and that is 0. Okay, then we've got negative 1 plus 3. Okay, because it's minus a negative 3, so it turns into plus 3. So negative 1 plus 3, and that's going to be a 2. Negative 4 plus 3 will be negative 1, and negative 4 plus 3 again will be another negative 1. And we can double check this again just by making sure this adds to 0, which it does. Next step is going to be our squaring of this column. Again, this is the same as our x minus m, except we're squaring it now. Okay, so 0 squared is 0, 2 squared is 4, negative 1 squared is 1, negative 1 squared is 1. So when you add those up together, you should get a 6, and that is your sums of squares. We want the variance, so we're going to take that sums of squares and we're going to divide by n minus 1. So I never wrote it anywhere, but I'm going to come back over here and just say my n is 4. So 4 minus 1, so 6 divided by 3, which will be a variance of a 2. Then we're going to get the standard deviation, because remember we have to get the standard error eventually. The standard deviation is the square root of the variance, so the square root of that 2. So that should be 1.41, so let's just see. Yes, 1.41. And then we need our standard error, because until we get the standard error, we're still in step 2. The formula for the standard error is your standard deviation divided by the square root of n. So I've got 1.41 divided by the square root of 4. So I've got 1.41 divided by square root of 4. So that should be 0.71. Okay, so that's your standard error. Now from there, we can move on and do step 3, 4, and 5. So I'm going to erase this over here so I have some space to work. Okay, so for step 3, we've got our graph. Let's just say we're doing a p-value of 0.05. Remember, the problem would have to tell you that. So if you are wondering where that came from, I'm just making it up. So we're doing p-value of 0.05. Our degrees of freedom here is n minus 1. So we have 4 as our n, so our degrees of freedom is 3. And it is one-tailed. Okay, so let me get my chart here. All right, so I got my chart, and I'm looking in the one-tailed section at 0.05 and a degrees of freedom of 3. And my cutoff is 2.353. And I have to figure out, am I going to put this on the right or the left? Well, if you think back to my hypotheses, which I did erase, my research hypothesis is that the mean of the difference scores will be less than 0 because I was expecting them to be negative, okay? So if you think of our graph here as having this little 0 point, all positive values are on this side, all negative values are on this side. So I am expecting it to be negative, so I'm expecting it over here. So my cutoff score of 2.353 will be a negative 2.353. Okay, so that's my cutoff score. So then for step 4, I'm calculating my t-value, which is the mean of my d-scores, which we found before was a 3, divided by the standard error, which was 0.71. Let's see. 3 divided by 0.71. And I got 4.23. Okay, so, oh, negative 3, sorry. It was a negative 3 was our mean. So that'll be a negative 4.23, which will pass our cutoff. And then step 5 will just be that we reject the null. And we say that coming to see me will make you less anxious, which is good. Effect size. Do I have any space on here to write an effect size? Maybe like, maybe over here? Yes? Okay. So remember the lowercase d is our effect size symbol for Cohen's d. And again, it's the mean of your d-scores, which for us was negative 3. But it's divided by the standard deviation, which was 1.41. So if we do a -3 divided by 1.41, we will get -2.13, which is a very large effect size. Large. You see that? Large. So we're finding that we're rejecting the null. We're seeing that yes, coming to see me is helpful, reduces your anxiety on average by 3 points, which is pretty good. And if you look at the effect size, that's pretty large, -2.13, suggesting that the effect itself is big, and it's unlikely, based on our 5-step process, unlikely that we would have gotten those kind of results just by chance. Okay, so that's sort of what we're concluding at the end. And so that right there was a dependent samples t-test from start to finish. Remember, anytime you see a before and an after situation, that's probably going to be a dependent samples t-test.